This is the third video to section 6.1, and we'll start out by taking a look at example 2, where we're asked to find the z-score of x equals 7 if it is 0.133 standard deviations to the left of the mean. Let's start out with a graphical representation of this. If we have our normal curve, and recall that our mean is in the very center of our normal curve, and our x value in this case falls to the left of the mean, and specifically it falls 0.133 standard deviations to the left of the mean. Then what is the z-score for this? Well, remember, if a value lies to the left or below the mean, that means its z-score is negative. So in this case here, our z-score will be negative 0.133. Negative 1.33 standard deviations away from the mean. Taking a look at example 3. Suppose we have our normal distribution with a mean of 4 and a standard deviation of 2. What value of x is 2 standard deviations to the right of the mean? So if we have a value that is 2 standard deviations to the right of the mean, what is that telling us? It's telling us that we have a z-score of positive 2. Positive because it's to the right or above the mean. And now we have to go ahead and find the x value. So we'll use our formula and plug in our values. And we'll come out with an x value of 8. Moving on to an example 4, where we have adult male heights with an average of 70 inches and a standard deviation of 4 inches. And then we have adult women with their average height of 65 inches and a standard deviation of 3.5 inches. For letter A, we're asked to let x equal the height of a random adult male and y equal the height of a random adult female. So let's go ahead and write this notation here. We're going to have a normal distribution for the men with a mean height of 70 inches and a standard deviation of 4. Whereas for the women, we have a normal distribution with a mean height of 65 inches and a standard deviation of 3.5. Whose height is more unusual? An adult male that is 6'4" or an adult female that is 5'11"? For a height of 6'4" that would be a total of 76 inches. And for women, where the average height is 5'11", that would be a height of 71 inches for our data point. Let's go ahead and compare the z-scores now by plugging in our mean and our standard deviation. So we have a z-score of 1.5 above the average for the men, and for the women we have a z-score of 1.71. So this has a greater z-score, which means a woman's height of 71 inches or 5'11" is more unusual than a male's height of 6'4". Moving on to the next page, we'll continue with the normal distribution, And we're going to talk about the empirical rule, or the 68, 95, 99.7 rule. If x is a random variable and has a normal distribution with a population mean and a population standard deviation, then the empirical rule states that about 68% of the values lie within one standard deviation of the mean, 95% between two standard deviations, and 99.7 within 3 standard deviations. For a better understanding of this, let's look at a graphical representation. Notice we have our mean in the very center. And from one standard deviation to the left and one standard deviation of the right, we have a total of 68% of our data falls within one standard deviation of the mean. Now, if we look at 2 standard deviations to the left of the mean and 2 standard deviations to the right of the mean, now we have a total of 95% of our data that falls within 2 standard deviations. Furthermore, if we take a look at 3 standard deviations to the left, 3 standard deviations to the right, about 99.7% of our data will fall within 3 standard deviations of the mean for a normal distribution. Consider example number 5. We have a normal distribution with a mean 25 and a standard deviation of 5. Between what values of x does 68% of the values lie? So if you consider our x-axis here, with a mean of 25 and a standard deviation of 5, that means if we go one standard deviation to the right of the mean, all we have to do is add 5 to our mean, and we'll get 30. One standard deviation to the left of the mean, well, that means here we'll subtract 5 from our mean and get 20. Now, the empirical rule states that 68% of our data falls within one standard deviation of the mean. So in this case, 68% of our data will fall between 20 and 30. Moving on to example 5. Go ahead and read this one for a moment and attempt these parts of the problem. Go ahead and play the video again when you think you've finished it. And how did you do for example A? Now for letter B, if a friend says their systolic blood pressure is 3 standard deviations below the mean, actually that is really unlikely because 99.7% of our data should fall within 3 standard deviations. So first of all, it's very unlikely, but that friend should most likely see their doctor because that blood pressure is extremely low. And what would his blood pressure be if it was 3 standard deviations below the mean? Let's go ahead and find that x value. And there we go. That is the end to the 3rd video of section 6.1.